Hello students, welcome to the video lecture series on Chemical Engineering Thermodynamics 2. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. So let's continue with the chapter number 2, which is Solution Thermodynamics. So in this lecture we are going to calculate various numericals based on partial molar property. So let's first consider this numerical. In statement told that in laboratory 30 mole percent of methanol water solution is to be prepared. How many of meter cube of pure methanol and pure water are to be mixed to prepare 2 meter cube of desired solution? So in statement given that there is a 30 mole percent of methanol. So can say that x1, let's suppose methanol is the component 1, so it's represented by x1 is equal to 0.30. Second component, which is the water, so 1 minus x1 becomes 0.70. So let's suppose this water is a component 2, so this water is a component 2, so x2 that can be given by 0.70. How many meter cube of pure methanol and pure water are to be mixed to prepare 2 meter cube of desired solution? Partial molar property of water are given. Partial molar property, or can say that partial molar volume of component 1 V1 bar is equal to 38.632 centimeter cube per mole. Now in statement told that how many meter cube of pure methanol and water required. So we have to convert this centimeter cube into meter cube to get answer in meter cube. So if we are going to converting this centimeter cube to meter cube, we have to multiply with 10 raised to minus 6. So V1 bar becomes 38.632 multiplied by 10 raised to minus 6 meter cube per mole. Similarly, for V2 bar, we can say that 70.765 multiplied by 10 raised to minus 6 meter cube per mole. Then other data is given, molar volume is given, molar volume V1 is equal to 40.227 centimeter cube per mole. So if we are going to converting in meter cube, we have to multiply with 10 raised to minus 6. So it becomes 40.227 multiplied by 10 raised to minus 6 meter cube per mole. Similarly, for V2, we can write 18.068 multiplied by 10 raised to minus 6 meter cube per mole. So these all data are given in statement. V1 bar, which means partial molar property, or can say that partial molar volume of component 1. Component 1 is a methanol, so this is a partial molar volume of methanol and partial molar volume of water, and this is a molar volume of methanol and molar volume of water. Now in statement told that we have to find out pure methanol and pure water volume to be prepared 2 meter cube solution. So we have to make 2 meter cube solution in which there is a 30% of methanol. So 0.30 methanol required and 0.70 water is required to make this 2 meter cube solution. Now we cannot just make a solution by adding 1 meter cube of water and 1 meter cube of methanol. Okay, it makes 2 meter cube solution? No, because if we are going to mix two different component, partial molar property to be in action, so we cannot get 1 plus 1 is equal to 2 meter cube solution for this different component. If we are going to add 1 meter cube of water and second is also water, 1 meter cube of water, then it makes 2 meter cube solution. But for different component, there will be a partial molar property comes in action for making solution, and we cannot get 2 meter cube solution. So if we want to make 2 meter cube solution of 30% methanol and 70% water, what we have to do? First, we have to find total volume of solution. How we can find total volume of solution? So in statement given that partial molar volume of particular component, so partial molar volume, this both V1 bar and V2 bar. So using this partial molar volume, we can find out the total volume of solution. Then after, what we have to do? We have to find how much mole required to make 2 meter cube solution. So first we are going to find out, then after finding total volume of solution, we are going to find out the mole required to make 2 meter cube solution. After finding the total mole of that solution, we can find the individual mole for particular component. To find out the individual mole, what we have to do? So first we have to find the individual mole for particular component. So what we have to do? We have to just multiply 0.30 with this total number of moles. So we will get the methanol moles, and 0.70 with this total number of moles, we will get the moles required to make 2 meter cube solution for water. Then after, we are going to find volume, or can say that individual volume, to make 2 meter cube solution. So to find out 2 meter cube solution, we have to find the individual volume that can be calculated by using individual mole multiplied by this molar volume. So using this molar volume with individual mole, we can find the individual volume for this solution. So in simply can say that first we have to find the total volume of solution, then we are going to find total moles in that solution. After finding total moles, we are going to find the individual mole for particular component. Using individual mole of component multiplying with the molar volume, we will get the individual volume which required to make 2 meter cube solution of 30% methanol and 70% water. So let's first write, or let's first find total volume of solution. So to find the total volume of solution, there is an equation that can be given by V is equal to x1 V1 bar plus x2 V2 bar. Value of V1 bar and V2 bar given in statement. So if we are going to put the value of x1 and V1 bar, what is x1? x1 is a 0.30, V1 bar given in statement. V1 bar is a 38.632 multiplied by 10 raised to minus 6 plus x2. Value of x2 is a 0.70, 1 minus x1, which give value of x2, which is a 0.70. Value of V2 bar, which already given in statement, which is a 70.765. So 70.765 multiplied by 10 raised to minus 6. So here, if I am calculating this term, I will get the total volume 24.0251 multiplied by 10 raised to minus 6 meter cube per mole. So this becomes our total volume for the solution. Now we have to find the mole required, or can say that total mole for the solution to make 2 meter cube solution. So if we are going to find the total mole for solution, what we have to do? We have to just dividing 2 meter cube, or can say that this 2 meter cube divide by total volume of solution, that is 24.0251 multiplied by 10 raised to minus 6 meter cube per mole. So this meter cube cancel and we will get the mole. So this mole that can be given by 83.2463 mole required to make 2 meter cube solution. So this is a total mole required to make 2 meter cube solution. Now we have to find the individual mole. So to find individual mole, we have to just multiply with their mole fraction. So let's first find for the methanol which is a 30%. So can say that 0.30 multiply by this total mole which is a 83.2467. 83.2467. If we are going to multiply this term, we will get the total number of moles of methanol in solution that can be given by 24.9739 multiplied by 10 raised to 3 mole. So this much amount of mole is required to make 2 meter cube of solution for methanol. Now let's calculate for the water. So how much mole required to make 2 meter cube of solution? So mole fraction of water is 70 multiplied by total number of mole of solution which is 83.2467. So if we are going to calculate this numerical or this term, we will get the answer which becomes 58.2724 multiplied by 10 raised to 3 mole. Here total mole is 83.2467 multiplied by 10 raised to 3. Similarly here 10 raised to 3. So if we are going to do calculation for this both term, we will get this answer. This is a mole or can say that number of mole of methanol which required to make 2 meter cube solution. This 2 meter cube solution in which 30% methanol and 70% water. So this much amount of methanol and this much amount of water mole and can say that number of moles required to make this type of solution. But in statement told that we have to find out the meter cube of pure methanol and pure water. So we need to find out the volume. To find out the volume, we require mole for the methanol and mole for the water multiply by molar volume of methanol and molar volume of water. So this is a mole which already given and molar volume that given in statement which is a V1 and V2. So let's find the volume required to make 2 meter cube solution. In this 2 meter cube solution 30% methanol and 70% water. So let's first calculate for the methanol. So volume required for methanol to make this type of solution is equal to mole of methanol for making 2 meter cube solution which we already find and molar volume of methanol. So mole of methanol for 2 meter cube solution which already find which is a 24.97. So 24.9739 multiplied by 10 raised to 3 multiplied by molar volume of methane. Molar volume of methane that can be given by 40.727 multiplied by 10 raised to minus 6. So if we are going to calculate this term, we will get the volume which is required to make this type of solution that can be given by 1.0171 meter cube. So this much amount of methanol required to make 2 meter cube solution for in which 30% methanol and 70% water. Now similarly we can also calculate for the water. For water the mole of water for 2 meter cube, which is of 58.2724. So 58.2724 multiplied by 10 raised to 3 multiplied by molar volume of water. Molar volume of water which is given in statement, which is 18.068. So if we are going to multiply 18.068 multiply by 10 raised to minus 6, we will get the answer. By calculating this term, we will get answer 1.0171 meter cube. So this much amount of water is required to make this type of solution. So to make 2 meter cube of solution in which 70% is water and 30% is ethanol, we require pure amount of water which is 1.0529 meter cube and methanol that can be given by 1.0171 meter cube. So this much amount of volume required to make this type of solution, or can say that 2 meter cube solution. So this is all about today's lecture. I am completing my lecture here. Thank you.